Hello, friends. My name is Alberto Medina. I'm a pediatric consultant in the PICU of the University Central Hospital of Asturias in the north of Spain, Oviedo. This talk is focused on the use of mechanical ventilators in saving lives. The concept of mechanical ventilation has a long and ancient history. References to the technique can be found in the text of Hippocrates' treatises, of course, also in the Vesalio books, but it is not until 1911 that the Draeger company released the first device which delivered intermittent positive pressure. This device was called pulmotor. And the polio epidemic in the 1940s led to a proliferation of negative pressure ventilation systems referred to as the iron lungs, as you can see here in this picture, a very old picture. Since then, due to the difficulties providing this type of negative ventilation, several modes of intermittent positive pressure mechanical ventilation have been developed. In the last few years, advances in technology and computing have enabled the production of ventilators and ventilation modes that are more efficient and, importantly, more land protected than have been available previously, thus limiting the adverse effects that can be caused by this ventilation. This is partly due to advances in lung function monitoring, for example, curves, loops, and resistance and compliance measurements, as a result, of course, of this technological development. A ventilator is a compact piece of equipment which allows mechanical ventilation to be carried out. In the majority of the ventilators at the back, there are connections for electrical power and medical gases connections, and there is also a general switch and computer connections for data acquisitions, as well as a system for cooling the equipment. Inside the ventilator, there is always a gas blender, which allows a supply of non-oxygen concentration within a range from 0.21 to 1 for inspired gas. A fundamental part of the ventilator is the inspiratory valve to regulate the gas output. It allows to open or close the gas flow, as well as the different variation in the magnitude and duration of the flow. The system permits inspiration as well as generates the pressurization of the inhaled gas. For this to occur, the expiratory valve must be closed. The main function of the lungs is to obtain oxygen from the cells to carry out their metabolic function and to eliminate carbon dioxide. The main objective of respiratory mechanical support is to maintain adequate gas exchange in order to meet patient metabolic demand. This should be achieved with minimal lung injury and hemodynamic side effects. It is therefore necessary to have a good knowledge of the characteristics of the principles of the different ventilation modes in order to choose the most advantageous for each patient and clinical scenario. So, an adequate technology provided by the companies, as well as an adequate knowledge and understanding of the principles of mechanical ventilation, are essential to provide adequate respiratory support and, in summary, save lives, not only during pandemics. So thank you very much for your attention.